Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to our foundation school system. This is class 9 physics. In our previous lecture we discussed about tension and acceleration in a string, and we calculate tension and acceleration for the case number 1 of this topic. Case 1 of this topic was when both objects move vertically. In this diagram you can see that the bodies of mass m1 and m2 are moving in the vertical direction, and we calculated the tension and acceleration for this case in our previous lecture. Today we are going to move towards case number 2, which says that when one object is moving on an horizontal surface as shown and one is moving in vertical direction. You can see that the body of mass m1 is moving on horizontal table or horizontal surface, and the body of mass m2 is moving in the vertical direction. In this diagram you can see that a body of mass m2, let's say this body is B, is attached with a string and placed over an horizontal table. This string is passing over a frictionless pulley, and the other end of string is attached with a body of mass m1, and let's say this body is A. And now we are going to calculate the forces acting on the body A. And since the weight of this mass A is acting in the downward direction, and due to its weight a tension T is produced in the string. Since the weight is in the downward direction and tension T is opposite to the weight in the upward direction, since weight of body A is greater than the tension, that's why net force on A is m1g minus T. That is weight minus T, because weight is greater than the tension. Applying Newton's second law of motion, the net force F is equals to, for this body A, is m1a. So our equation number 1 is m1a is equals to m1g minus T. Let's say this is our equation number 1. Now we are going to calculate the forces acting on the object B. Since the object B is placed over a horizontal surface and its weight is acting in the downward direction, according to Newton's third law, there must be a reaction opposite to this weight, that is the reaction of this horizontal surface, and that is in the upward direction. So there are two forces here we see, and there is another force that is move this body in the horizontal direction, and that is the tension T. So there are three forces acting on the body B. These are the weight of this mass m2 in the downward direction, the reaction of the table opposite to the weight, and the tension T in the horizontal direction. Since weight and reaction of the table cancels each other effect, and the body B only moves in the horizontal direction, so we can say that net force on B is only the tension T in the string, which causes the body B to move in the horizontal direction. Applying Newton's second law of motion, and our equation number 2 is m2a is equals to T. Now we move towards the calculation of acceleration. For calculation of acceleration, we put the value of T from equation 2. This is our equation 2. From equation 2 in equation 1, and let me show you the equation 1. This is equation 1. We are going to put the value of T from equation 2 in equation 1 for the calculation of tension, for the calculation of acceleration here. m1a is equals to m1g minus T, and T is equals to m2a, and instead of T we put m2a. m2a here, m2a is subtracting. When we shift m2a on the left hand side, it is added. So m1a plus m2a is equals to m1g. A is common in these two quantities, so taking a as common, so m1 plus m2 is equals to a is equals to m1g. This quantity m1 plus m2 is multiplying with a. When we shift it towards right hand side, it will be divided, and we get the expression for the acceleration produced in the string. So this is our acceleration produced in the string, and this is the expression for the calculation of acceleration. Now we move towards the calculation of tension. For the calculation of T, putting the value of A in equation number 2. This is the value of A, and we put in equation number 2, that is T is equals to m2a, and instead of a we put the value of a, that is m1g divided by m1 plus m2a, multiplying m2 with m1, and we get the expression for the tension in the string, that is T is equals to m1 plus m1 m2g divided by m1 plus m2. This is the required expression for the tension T in the string. So this is all about tension and acceleration in a string. If you have any problem regarding these two cases of this topic, then you can ask me in comment section. Now let's move our next topic, and that is force and momentum. Force and momentum, what is the relation between force and momentum? It's the relation between force and momentum says that when a force acts on a body, it produces acceleration in the body, and this acceleration produced is equals to the rate of change of momentum of the body. So this is also known as Newton's second law in terms of momentum. And when a force acts on a body, it produces acceleration in the body and will be equal to the rate of change of momentum of the body. Let's suppose momentum of the body having initial velocity vi is equals to pi is equals to mvi, and similarly we can say that momentum of the body having final velocity, that is vf, so pf is equals to mvf. So change in momentum is equals to, very simple, final momentum minus initial momentum. Rate of change of momentum is equals to, so change in momentum is equals to pf minus vi is equals to mvf minus mvi, taking m as common, so m into vf minus vi. So rate of change of momentum is equals to pf minus pi divided by t, and m into mvf minus mvi divided by t. So rate of change of momentum is equals to m into vf minus vi divided by t. We know that vf minus vi is equals to, vf minus vi is equals to a, that is acceleration. So putting this value in above expression, we get pf minus pi divided by t is equals to ma. According to Newton's second law of motion, F is equals to ma, so pf minus pi divided by t is equals to F. So rate of change of momentum is equals to the net force. So this we can define this as when a force acts on a body, it produces an acceleration in the body, and this produced acceleration is equals to the rate of change of momentum. Here we proved this expression. If you have any problem regarding these two topics, you can ask me in comment section. Thank you so much. Allah Hafiz.